In the last section, we finished up our k-nearest neighbor algorithm inside this little code editor over here. So we're now going to take all this code and move it over to our code editor for the Plinko project and run it for the real data set. So we're going to do this in a couple different steps. The first thing I'm going to do is pull over that distance function. We're going to eventually modify this distance function to make sure that our k-nearest neighbor algorithm works for multiple variables as well. So I'm going to cut this thing, and I'll go back over here, and I'm going to paste it underneath run analysis. Next up, I'm going to take the entire chain right here. I'm going to cut all of that and move it back into my run analysis function over here. And then I'll do a little bit of indentation just to clean it up like so. And then finally, the last thing we have to do is define our prediction point and our k value as well. So I'm going to cut both of those, and I'm going to paste them in at the very top of this file as well. Okay, so that's pretty much it. Now, last thing we need to do is to make sure that we take whatever the nearest bucket is for the point we're trying to predict and actually print it out once we run this analysis. So I'm going to assign the results of this entire chain to a variable that I'll call simply bucket. I think that's reasonable. And then at the very end down here, I'll console log bucket. And how about we put in a little bit of reporting information here as well? We'll say something like, your point will probably fall into bucket, like so. Okay, so that looks pretty good. Now, the last thing we have to do is flip back over to our browser and test this. And you know what? One last quick thing we're going to fix here. Remember on score update, we put in that console log. I don't think we really need that thing more, so I'm just going to delete that very quickly like so. Okay, so now we'll flip back over to our browser. I'm going to go back over to our Plinko project, and I'm going to refresh the browser page. So now we need to first make sure that we drop a bunch of different balls in different places all around the board and record all that data. We already wired that stuff up with our onScoreUpdate function right here. So all we have to do is get our Plinko board to drop a ton of balls and then record those data points, and then we can run our analysis by clicking on that Analyze button down here. And you might notice that there's a couple of tools on here on the right-hand side that can be used to very quickly get a bunch of data put together. So you can use this drop a bunch at various spots right here, this little section right here, to very quickly drop a ton of different balls all over the place. You'll notice that the default inputs are 10 and 200. So that's going to drop 10 balls every 200 pixels along the top edge. Let's try clicking on drop right now and seeing what happens. Okay, there we go. So that is 10 balls every 200 pixels. Now, of course, we want to get a whole bunch of data. So let's try updating these values a little bit. Let's say that we want to drop 10 balls, how about every 10 pixels? So that's going to be dramatically more all falling at once. So now click drop, and you notice that your browser might lag just a little bit, and they all fall down there. Maybe I'll do like one or two more quick, just to get a really robust sample size. Okay, so that looks good. So now last thing we have to do is click on Analyze down here. That's going to run our k-nearest neighbor algorithm and print out the bucket that we are most likely to have a ball fall into if we drop it at exactly 300 pixels. So I'll click on Analyze, and it tells me that dropping our ball at 0.300 is probably going to fall into bucket number 5 right there. So now the last thing to do is actually test out this assumption. So I'm going to click on Reset down here to reset all the bucket counts. And then I'm going to drop a bunch of balls at a single spot. So I'm going to drop 100 at exactly 0.300. And hopefully, we're going to cross our fingers, hopefully we're going to see that most of them are going to fall into bucket number 5. All right, so I'll click on drop, and they all come out. And lo and behold, it looks like, well, 11 got in there, but there was certainly far more that got into bucket number 4, and even more that got into bucket number 3 and bucket number 2. Let's try repeating this one or two more times and seeing what happens. So it looks like it kind of caught up there, but still, bucket 4 clearly has a greater representation than what we got for reality on 0.300. So let's take a quick pause right here and discuss some of these findings.